Well, hi, good morning. Thank you for joining me in my shop, and thanks for the super thanks. And look at this radio here. So this morning when I woke up and eventually looked at my phone, I saw that the Canadian government, Environment Canada, is warning of heavy smoke in my area from forest fires. So I think we'll start out, never mind the radio, let's take a look at some smoke in the sky. So this is a website called firesmoke.ca. It's a Canadian website, and some researchers have put together this website. The idea is obviously it's showing how the smoke is traveling from Canadian fires through Canada and also into the United States, as you can see on the map. I live over in this area right here where my hand is. If you notice, I live pretty far south. I'm in Canada, but look, I'm this far south. Yeah, Canada dips down where I live. And the smoke is coming. So now, looking at the smoke map's a little bit tricky. This is a forecast predicting the future. So it covers what has happened for one day, and then it projects 2 days into the future. And you have to look for the date. Here's the date here, June 25th at 12 noon. So that's a couple hours from now. And then the slider bar, you can slide around, or it will move on its own. So let's put it right to the start, just let this play. So it's about 3 days worth of smoke here. Does not look good for us. So I think this is more or less tomorrow. Now, this is just basically based on expected wind patterns. And look, I'm in the clear. Back in the clear in a couple of days. But of course, this is just a forecast. This is somebody's guess on it. And of course, this dark area is very serious. There's been a couple of times this year so far where I've gone outside and I can smell the smoke. Smoke coming from the fires up here in Quebec. We just go in a little closer on where I live. And we'll run this one more time. So I live right where the hand is, right there. So you can see it's already showing. This is 5 o'clock this morning. Smoke in the air. The other day I got up and the sunrise kept going. So I'm covered in fairly heavy smoke, and there's the blast right there. So that's coming tomorrow evening. And again, I live right here. Now, this is a forecast, so it may not really work out exactly like that. This is why, and then here we go. I'm in clear air, but it's not perfectly clear. I mean, there isn't a line. This isn't a cloud. There isn't a line here. This is a degree of smoke, and you can bet there's smoke in here too. It's just thin enough that they're showing it this way. Yeah, no wonder I'm not doing much astronomy this summer. The sky is just not right all the time. So, okay, that's the smoke situation here. Okay, let's get ready for a alignment here. Now, some radios you have to access underneath to do an alignment, not this one. Even though there is a capacitor sitting right in the corner there. Can you kind of see it? A little hard to see right down in there. I should be able to lay this radio down. Now, is there a bottom plate for this radio? Yeah, it's got the holes here. I don't remember there being a bottom plate. I actually don't see any evidence there was a bottom plate on it. So either there never was one or it went missing years ago in somebody else's shop. Yeah, I have a small collection of bottom plates that I failed to put back onto radios. And the radio's gone. And I've got the plate. But not this one. So that capacitor can be adjusted here with this adjustment. So everything can be done from the top. And I guess if you were careful enough, you could do everything with this actually in the cabinet even. But don't need to do that. First thing you want to do, didn't I do this? I did a rough job on this, or at least a check of the IF tuning here. So we're going to do that. If I get through that today, that'll be pretty good. in itself. Okay, first things first, I haven't drank any coffee yet. Okay, I'm half ready to go here. What I'm going to be attempting to do is put a sweep signal, a signal varying in frequency, through the IF transformers here, and then observing the result of that. And you know, I just realized, you see my scope there, I never hooked up an input lead to it. I've got nothing hooked up to it. Well, okay, so that's a good question right there. So what is it you want to watch on the oscilloscope? One choice is to watch the signal reaching the speaker. You literally hook the scope up to the speaker, which is under here. The problem with doing that is you have to listen to it, sometimes at a fairly high volume. So that's not the most attractive way to do this. Another way is to try to pick it up where the signal has just been detected. And that is usually right at the volume control in a smaller radio like this. The input lead to the volume control often carries a voltage on it, a DC voltage, a negative DC voltage, that's developed by the signal passing through the IF. Better signal through the IF, better voltage at the volume control. We're not talking about the stuff you hear coming out of the speaker. We're talking about a DC voltage. It doesn't come out of the speaker at all. You can't hear it. That, in fact, it's prevented from getting towards the speaker, the DC voltage part. But I can hook up my oscilloscope to it. Small difficulty there is I have to get underneath the radio again, and I got to connect this lead up. And we're not going to see much on the oscilloscope at the rate I'm going. And what's going to happen then when we're looking at the output from these two transformers is I'm going to be feeding a signal in just ahead of these transformers, probably right into this grid here. The signal will go through these two and then come into the lead to the scope. Now we're going to see what it looks like. And I can talk a little more if I manage to make this work. Sometimes this is difficult to make work properly, like I'm having trouble right now. I'm trying to figure out how I'm going to do this. Volume control is over here. I want the lead to kind of sit inside like this. Let's tip it this way as far as I can. Okay, look at the volume control. Detect the input side of it. So this is the grounded side, this is the input side. So I'm going to want this to be, this isn't going to work out. So I'm going to use a clip lead. I can't put that probe underneath the radio, that's too long. Do I not have a little bit of a shorter one? I do not really. Okay, we'll use this great big long one here. So we'll go on the volume control, input side. Just lay that down, hoping it doesn't come off or short to anything. Okay, now we'll take the lead here. We're set on the times 10 setting right now, which is probably a better setting to start with. Put that on the ground, and then we're going to clip this on the clip, like so. That should provide a signal to the scope. Make the scope a little less sensitive here. Make sure it's on DC. Just fiddle around with the adjustments here. So we're on 0.5 volts per division DC input. Now the sweep on an oscilloscope is usually generated internally, but in this case the sweep is being generated by this guy here, the sweep generator. This is the sweep output. It's coming along into here. And then the scope has a special setting, as a lot of these scopes do. You flip it to something, usually it says XY or something like that. And the scope sweep is then created by some external. It's looking for an external signal. The scope is looking for an external signal. This is the main output coming from the sweep generator. Now, there's a couple things I could do with this. I could put it on the antenna input. I think that would probably work. Maybe we're going to start there. I could put it right on here. It's almost the same as putting it on the antenna input. I'm not sure it's any different. They don't really want the radio operating, but I don't have an antenna on it, so it probably won't be much coming through the radio, so to speak. But if I want, I can probably pull this off, and that'll cut the signal coming from the antenna. Cannot reach the first tube. And I could do this kind of thing. Put a ground on here. Could connect there. But I got another idea. I got a different idea. Let's start with the antenna connection. We'll utilize that. We'll start there. That's what I'm going to do. Okay. Now things must be warming up and drifting a bit. I see this is a little off center. So the frequency range, the sweep generator is operating through is, let me just check. It's supposed to be 415. Everything's warming up a bit here. Set this to 4. That's as close as I'm going to get. 415. Stopping at 4. It should be 95. I'll make it 94. There. Turn the sweep back on. Now, so this represents 415 kilohertz, and this represents what I say, 495, something like that, over here. And the IF is resonant in the middle, so we should see something like that. That's what we're hoping for. Let's see if I actually manage to do this. I guess we just need to turn on the radio at this point. Okay. Double check. So I just have two grounds in the same place right on the chassis. This is clear. I think we're good to go here. Little jump there on the. Oh, let's put this back on. Now most of these tubes have a grid cap on the top, and you can probably touch it safely, but there are tubes where there is a plate cap, and the plate is carrying a couple hundred volts, and this thing's just sticking out. So be careful. So there we are. The sweep is sweeping, but there's virtually no signal level coming over here. So we don't hear anything. And make sure we're on AM too, because yeah, we're not. There, now we hear it. Now we hear it. Oh my gosh, look. Oh no! You're not supposed to see something like that on the scope. No, okay, maybe we should stop right here. So this radio is working very well, and I'm inclined to not change a thing. Yet that display, on the face of it, is suggesting that these transformers are way out. They should be aligned, but they're like this right now, or something's going on. Oh my gosh! Here we go again. Nothing is simple with this radio. Now, is that a suitable display to work with? You can kind of see over here. There's another one trying to come along. Oh, what's this thing? Can you see that little thing there jumping along? There's some strange stuff happening here. So I'm gonna guess that this thing that's traveling along here may be the buzz of the hum you're hearing, and yeah, I don't want to say any more about it because I'm just taking wild guesses here. Okay. Well, what happens if we stick the input in at here? Let's try it. Or if I got this turned up so high, I do in fact, even though I have the amplitude set minimum here, I've got the pads right up. So let's put some pads in. I think I'm probably just overloading the radio here. No, I don't think so now. No, they don't go away. Sometimes when you overload things, you get extra stuff in a test like this. But that's not what's happening there. Okay, I can also make the scope more sensitive, which I think is a good move. I make the scope more sensitive and cut back the input level. Scope more sensitive. And there's a DC voltage sitting there. That's the AVC voltage. I'm just adjusting it here with the scope setting. Now you can really see these little blips here just traveling along. Who are those guys? Why is this here? Let me turn up the level just a wee bit. Because we can listen to this on the speaker. It gives us some notion of... So I barely got the radio turned up and we can hear it. So I think that's good. I think all is good. I think we're ready to go. I think this is really something. So first thing to try, we'll try turning these. We'll try tuning the radio first. Oh my gosh, look at that. Good thing I did this. So because I'm coming in at the antenna, I'm getting antenna signals mixed in with it. And so this other thing here, so the radio is actually tuning this moving signal in. Let's do this another way. Let's try this another way. Take this off. Take this off. A less invasive way. And not that putting something on the antenna is very invasive. It's actually not. The radio is built to have something on its antenna. But I'm going to try to sneak the signal right into this tube here. We're going to try. We're going to turn it up because the loop's not very strong and put this bingo. So I think this might be a better way of doing it. I think. And I can even pull this out. Maybe not. Let's turn the volume down here. Pull this off. Can you still do this thing? Oh yeah. Oh, that's the best. Still see the other peaky thing, but not much of it. What I'm talking about is this. This is the main IF, and this is the tuned in signal, right? Yeah. So we just ignore it. I think this is very good how I'm doing this. We're just going to lay that like that. We're going to cut the signal back. We don't want too much signal coming in the radio. Maybe even make the scope a little less sensitive. There we are. So what's happening now is, if I'll slow this right down. Right now it's sweeping through, I don't know, 50 times a second or something. Well, you can hear the buzz. The buzz lets you know, what's that? 50 times a second or something like that. I'm going to slow it down to once per second. Something funny happened here. That's not what I expected at all. Let's go once every 10 seconds. It looks like some astronomical event taking place. Whoa! Something not working right there. Okay. Here's a slower speed, but still fast enough to make an image. So the sweep is going through, frequency-wise. It's going up. And as it crosses the tune point, it dips down like that. Let's put it full blast again. Did I lose some strength there somewhere along the line? Now we need to know what this frequency is. And the only way for me to know it is to bring in another signal generator. And I happen to have one right here. So we will mix this in with the other signal. One way to do that is to hook it right up here. Another way would be to take another coil. Because I just assume not mix my equipment together. I don't want to learn certain things the hard way. Like those people in the submarine. Gamble away all you like, all your life. But don't gamble your life. For what? A chance to see some rusty Hulk? Wow. Wow. So I'll just put this like this, and we'll hope that somehow it's going to allow the other signal generator to get involved here. I'm just letting it warm up over yonder. My frequency counter has gone wacko again. So we want this to be at 455. So 455 is going to be 455 kilohertz is what I'm saying. I wish this would stop. We'll get it roughly 455 if I can get down. And then I gotta read this. This is, if I can get right down. 455 would be right around here. Okay, we'll have to wait for the counter to stop to get it exactly on. Now I'm going to raise the output level of the, let's call this the marker generator, and the other one is the sweep generator, right? Sweep generator, marker generator, because it's going to mark. It's going to mark 455 kilohertz for us. At least that's my hope. Okay, my counter is stopped. It's at 465. I'm going to up the output level here. I'm going to sweep this one manually back and forth. I'm going to watch the scope and see if anything happens. Anything happen? Yes, see right there? Can you see how it's gotten all shaky and wiggly? Very tricky to get a really good image here for the camera. So I can certainly see in detail. Hey, what if I swing this really close? The cord is yanking the camera here. See a little bit better there now. How shaky this is. Now I'm going to move this the marker generator off. Okay, so if you watch really carefully, you can kind of tell. Not so good here. I got this full blast. Ooh, she's full blast all right. Sometimes you can see the other marker generator coming along and then going down the dip and coming up. In this case, we really can't see that. See, it's here on the knee right now, and then it's coming down, and then it's down at the bottom here. See how shaky that got? Just get it balanced. I think you probably can't see this well. There we are. So I have now set the marker generator to the frequency of this dip. And if we take it, oh, you can see what the frequency is. You were watching the whole time. 455, bang on. Well, I adjusted this earlier. This is just a verification that it's correct. It's absolutely correct. Excellent. So there's nothing to do with the IF. What I didn't do last time around was adjust these guys in here and this one. And that's what's got to come next. So that's a different kind of test. I have to set up a little differently for it. This was an interesting little experiment here. Once again, you could hear that AVC effect. Very loud and then quiet down. Can we actually receive that station with maybe not. No, I'm not a good antenna. Don't use me for your antenna. Okay, so I'm going to take a short break. I'll set things up for doing the remainder of the alignment. This will be very tricky. I don't have any alignment instructions for this radio, or do I? Yeah, okay, break time. If you've watched lots of my videos, then you know I like to kind of take a bit of an experimental approach to stuff, and I just performed an experiment by accident, so I'm going to show it to you. I just went to pick up the output lead from the signal generator there, and I accidentally touched it. Hey! How's that happen? Now, of course, I personally am not grounded in here. I'm wearing rubber soled, I'm not now, put it back on. rubber-soled shoes, and I'm not on a concrete floor. I'm on a rug on top of a tiled floor on top of concrete. I am floating here, floating electrically. And if I touch this, well, I am now carrying the signal from the signal generator. But if I touch the ground here, it'll disappear. Well, it got weak. And if I touch it right here. Ooh, love the experimenting. What's happening here? How come the radio is picking me up? How come I can put my hand over it? Now, the reason the scope is going down is because I'm increasing the signal strength and it's producing a AVC voltage. And so that's why it's going down. We can fix that if I just flip this to AC, and we'll just move this down. I can actually see even when I'm not actually touching it. So what's happening? How is this signal getting into the radio? There's no antenna connected. So I suspect it's going in through the tube. It's going in through these coils. Well, of course the coils are in metal cans to prevent this from happening and to prevent their own signals from coming out and getting into other radios and that. So something is somewhere. I am the instrument of my own demise here. Well, we can't figure anything out doing this. I'm too clumsy. My electrode is, it's a lousy electrode. Interesting. I think from time to time I have radios in here that are picking signals up, just like this one, right into the IF, because this is an IF frequency here we're doing this with. It's going right into the IF. It's getting in through wires like this or other ways and showing up in the speaker, but you don't know that that's where it's come from. You think, oh, it must be coming in on the antenna. That must be part of the regular signals that you find on an antenna that's making the sounds I'm hearing. But in fact, it could be something like this. There we go. Experiment done. Now, what I do want to do is I want to turn this back. I want to set this up to just to get going here. We'll start right in the middle of the radio's reception band, just for fun. So that's 1,000,000. What's 1 megahertz? We'll set this to 1 megahertz also. Okay, just got it right on the money there. And now we're going to feed this signal into the antenna. Hey, if this is really tuned, it's going to come right out. We're going to hear it on the speaker. Put this on the ground here. Let me use this connection again. Okay, put this on. The signal level is moderate. There it is. So that's a good sign right there that I was able to tune this radio ahead of time. The oscilloscope is no longer a critical factor. Let me just change the way it's set. But I'll leave it on because it's fun to look at. Let's see if I can just steady that guy up. Why so fat? Why not just a nice skinny line through here? Good question, Jim, but I'm not going to answer that one right now. I think I have an answer for that. Okay, we'll turn this down. We don't need to hear it just a wee bit. This other signal generator shut off. Make sure nothing funny is happening. Like I just showed you. Funny things can happen. Okay, fantastic. How accurately is it tuned? Well, pretty good. Wow. And if you look at the front dial, I mean, it doesn't get any better than that. Right on 1,000,000. And read the number here, 1,000,000. It's bang on in the middle. That's pretty good. Usually you're adjusting these things at the high end or the low end, the extreme tuning area. Now, so there's an adjustment for the oscillator which will control the accuracy of the pointer. That adjustment must be pretty good because the pointer is very accurate, so I don't want to adjust that. I got 4 things to choose from, 5 things to choose from to adjust. Some of them are going to be for the short wave, and some are going to be for broadcast. And a metal screwdriver, I'm going to try to, without turning anything, I'm going to try to interfere with it and see if we can figure anything out about who's who. Now these are capacitors, generally, no interference, but we'll see. Tapping them might show something. I don't hear anything, I don't see anything. Likewise. Now normally you'd be looking on a schematic or an instruction. This is not working out at all. Okay, so that didn't help one bit. See, anybody mark these? Sometimes people write stuff on the side. No. Okay, I don't want to start turning them to figure out who's who, because the radio's working so well. Chances are there's no need to adjust this stuff anyway. Yeah, think about that for a bit. So I'm going to stop, look at the information I've got, see if I've got any informational hints as to who's who over here that might prompt us to try to adjust it. So I'm going to stop here for a bit. Well, as luck would have it, there is information here. So take a look at how they've drawn this drawing here. Let me just shrink it a bit. So if you look, you see a heady line right like this. And this heavy line is separating the upper part of the page and its information from the lower part of the page and its information, because they have two different radios on here. The upper part is model 8B61, the lower part is 8B62E. This is what I have. This diagram fits the radio. The tube arrangement here fits the tube arrangement in this radio, so the IF in the right place. This is the radio for sure. Let's zoom in on it, because all I need to know is written right here. So we have a high frequency, this is, we could say short wave antenna trimmer, broadcast antenna trimmer, broadcast oscillator trimmer, and short wave oscillator trimmer. So these two outside ones we're not interested in right now, because there appears to be no short wave in the radio. The antenna trimmer is you kind of have to have the antenna connected to it to adjust this properly. So I could adjust it here, but without the proper antenna adjusted to it or connected to it, I don't think I can do a rational job of it. And the broadcast oscillator is what's going to control the dial accuracy. And we just saw the dial accuracy is right on the money. I think it's reflective of whoever worked on this radio previously. Did all the right stuff to it. Fantastic. Fantastic. There's nothing here for me to do, really. That's what I'm saying. Nothing for me to adjust. Plus, the radio's performance is really good. What am I looking for? Really, what am I looking for? Fantastic. So what's happening here is a loop antenna is coming from Mr. Amazon. He sent it. It's coming. When the loop antenna shows up, I'm going to suggest to the owner of this radio that he take this antenna. I will then make the final adjustments on this radio. And now, what about the? Why don't we spend a little bit of time, because I'm not quite out of time yet today, and just see if we can. Oh, I don't know, jeepers. I'm thinking, let's fool around with the shortwave side of things. But in fooling around with the shortwave side of things, I put at risk a high-performance AM radio. Why would I do that? Because the owner really wants to listen to shortwave. Well, if you really do, there's better ways of doing it than with this radio. That's for sure. The discombobulation is probably in those coils I spent so much time on. Do I want to go there again? No, I don't. So I think we're done with this radio until the loop antenna comes later today. So what I can do, I can just shut it all off. I'll just stop the video, just leave it here, and then later this afternoon at some point, or whenever that antenna arrives, I'll bring it in, hook it up, and we'll give it a go. And then that's probably the last thing I'm going to do with this radio. Wonderful. It's really, this was a scary project for sure. So fantastic. Off it goes. Fantastic. Okay, I'm gonna go mess around. It's not raining today. I think it's actually some sunshine out there. My cats are out there, so I'm gonna go outside too. Thanks a lot for watching so far, Don't say goodbye yet, Jim, because there's going to be another section coming here. I think I could even do it in the evening. Who knows what I might do? I don't know. I'm going. See you in a bit. See you in a few hours. Well, it's only been a minute because I stepped outside and all I can smell is smoke. And I looked across the street and I can see the smoke in the air. Wow. So, yikes. Not going to be a very good day here, I don't think, for that reason. Anyway, okay. Wait till that antenna comes out. If I'm still alive then. The small loop antenna has arrived and it's time to check it out. So I have the radio operating here. I just tune in a station.
Probably won't see him today because he was actually signing autographs. Signed autographs for like an hour out there in left field. So good for him. He took that really seriously. But I feel like whenever you see that, it probably tells you he's not going to be asked to prepare too much. But on top of that, he's pitched 4 of the last 5 games. So.
Now I've had to move the antenna off my bench. Normally I would just stick it on the bench right next to the radio. But up here, nothing gets received. So I have an extension wire, which is leading to the antenna you're going to see in just a second. This is an AN200. I'm not promoting this antenna, but I'll tell you that it works really well. I bought quite a few of them. I have no relationship to the supplier or anything like that. This isn't an advertisement in any way for their antenna, but it sure works to me. So here we are. This is it. Right there.
I would agree with that. He did maybe struggle a little with a couple of values. Raised some question marks, but if you look at his stats, it has been in the lead.
Also tuning here
no matter how you
on
play
and off.
He has wider usage, which again, raised some concerns or some questions here, but it's working.
It's a little awkward for me to operate this because I have to run back and forth, but I'm going to do that. We'll try another station. We'll try the French station, which is right around here. Of course, the antenna is no longer tuned. It's far off its tuning. So I'll bring it in, and you'll be able to hear the hiss on the radio come up. Okay, we'll hunt a little more for it here. There we are. So, although I'm not comparing it with my own great big loop antenna, I think it's pretty obvious. This guy works well. And like I said, I've gone through 5 of these. I keep selling them to people. I keep getting them for me and then selling them off at cost, basically. I'm not looking to make money on that. So that shows that if you add that kind of loop antenna, and by the way, a lot of these radios come with their own loop antenna, especially the small table radios. The loop antenna is mounted on the back of the radio, and it's serving the same purpose as this. If you have a radio that does not have a loop antenna, you'd be a lot better off to get one of these and connect it to your radio for AM reception only, broadcast band only. The antenna is useless on shortwave and the like. So that's it for this radio. It's going back into its cabinet and to be on its way home pretty soon. So thanks a lot for watching the series, and I'll probably do a short video of this beautiful looking radio once it's all back together, and that'll be it for this. And I'm on to the next radio, which isn't a lot different from this one. Thanks a lot for watching, and thanks a lot for the super thanks. See ya.